Hey everyone, today we are going on a little adventure. We're going to follow a single drop of water on its wild journey from a cloud all the way down to the ground to answer a question that's actually trickier than you'd think. What exactly is sleet?
So let's just start with the big one, right? Sleet or freezing rain. People mix these up all the time, but as we're about to see, knowing the difference isn't just for weather nerds, it's actually super important for staying safe when a winter storm rolls in.
To really understand what's hitting us down here on the ground, we have to start way, way up in the atmosphere. So we're going to follow the life story of one single particle of precipitation, from a super cold cloud all the way down to us.
Now here's a fun fact. It doesn't matter if you end up with snow, sleet, or freezing rain. The whole process almost always starts the exact same way. High up in the atmosphere where it is just incredibly cold, a tiny little ice crystal forms. And just like that, a snowflake is born.
Okay, but our snowflake's journey is not just a straight shot down through cold air. Oh no, it's about to hit a massive plot twist, this really strange atmospheric setup that meteorologists talk about all the time. Think of it like a temperature sandwich, a layer of warm air literally sandwiched between two layers of freezing cold air. This weird setup, it's the secret to everything.
So here we go. Step 1. Our brand new snowflake starts to fall, just tumbling through that very, very cold upper layer of the atmosphere. Right now, everything is totally normal. It's just a snowflake, doing its thing.
And boom, here's the twist. The snowflake falls out of that cold layer and right into the warm filling of our temperature sandwich. And in this pocket of air that's above freezing, our snowflake completely melts. It's not a snowflake anymore. It's just a regular old liquid raindrop.
Now, for the most critical part of this whole journey, our little raindrop keeps falling and it enters the second layer of cold air, the one that's right near the ground. Now, for sleet to form, this layer has to be pretty deep. It needs to be a nice, long fall through that freezing cold. And because that final cold layer is so deep, so thick, the raindrop has enough time to freeze solid again before it even hits the ground. It turns into this tiny, frozen ice pellet that hits your car or the sidewalk, and it bounces. And that is sleet.
So now we know the secret recipe for sleet, but let's see how this stacks up against its much more dangerous cousin, freezing rain. It all comes down to one thing, the thickness of that final cold layer we just talked about.
I mean, this chart just makes it crystal clear, doesn't it? For sleet, you have a thick layer of freezing air. That gives the raindrop time to freeze solid into a pellet before it lands. But with freezing rain, that cold layer is really thin. The raindrop doesn't have time to freeze in the air. It stays liquid, it becomes supercooled, and then it freezes instantly the second it hits a cold surface, coating everything in this slick sheet of glaze ice.
And really, that difference in hazard is the whole point. Don't just take my word for it. As atmospheric scientist Hannah Carmichael put it, a frozen pellet bouncing off the ground is one thing, but a freezing raindrop that coats every single surface with ice, that is a whole different level of dangerous. Okay, to make sure you're all true winter weather experts, let's just quickly clear up some confusion. We've got to talk about a couple of other icy imposters that often get mistaken for sleet.
So first up is something called graupel. You can think of these as soft, crunchy little snow pellets. They form in a totally different way. Water droplets freeze onto a falling snowflake. They don't start as a raindrop that refreezes. They're kind of opaque and they crush really easily, not like those hard, clear little ice pellets of sleet.
And then there's hail. Aw man, hail is in a completely different league. This is not a gentle winter thing. No way. Hail is formed in the crazy violent updrafts of strong thunderstorms. These things can get tossed up and down inside a cloud over and over, just growing bigger and bigger each time. And I mean, just look at the size difference here. It's staggering. Sleet pellets are tiny, 5 millimeters or less. Hail can be the size of a golf ball, a baseball, or even bigger. It's a completely different beast, born from a completely different and much more violent process.
Okay, so we followed the journey, we've met the imposters, but let's bring it all back down to earth. Why is it so darn important to get all of this right?
Well, here's the bottom line. Sure, sleet can make roads slick, but freezing rain? That stuff is so much more deceptive, creating that invisible black ice. And because it's a liquid that coats every surface, freezing rain is what builds up into that heavy, destructive ice that snaps power lines and brings down tree branches. Sleet pellets? They pretty much just bounce right off. And this is why a tiny, tiny error in a forecast, just a degree or two, can be the difference between a minor annoyance and a total disaster.
So, the next time you hear that winter weather forecast calling for sleet or freezing rain, you won't just hear the words. I bet you'll actually picture that incredible journey, that whole trip through the temperature sandwich in the sky. And you'll know exactly what's heading your way. Thanks for joining me on this one.